Hello, this is part 2 of graphing polynomials completely. So let's just move on to example 3. So we got to find graphing this by finding n behavior, y-intercept, x-intercept, and multiplicity. So let's start with rule 1 or step 1. Let's find the n behavior. It looks like our highest term is x4th. So what does that look like? And it has a coefficient 1, so that means there's no reflection. So this is an odd power, and how do all odd powers look like? They rise to the right and rise to the left. So it doesn't matter if this is x4, x6, x8, x10, as long as it's an odd power and there's no reflection, it rises to the right and increases to the left, okay? The next step is find the y-intercept. So how do you find the y-intercept? You plug in 0 into the function. That's 0 to the 4th minus 4, 0 squared, right? So that's going to be 0. So your y-intercept is 0, 0. Then we find our zeros and multiplicities. So set y to 0. And it looks like we could take out, with our factoring rules, I could take out a GCF and I could take out an x squared. So this is going to be x squared minus 4. And then x squared minus 4 is a perfect square. It could be factored out as x plus 2, x minus 2. So your zeros are 0. Well, we got that 0 from here. Now, this has a power 2, so that means it's an even multiplicity. So even multiplicity means it bounces. Your other 0 is -2. We got it from here. This has a power 1, which is an odd, so we know it crosses. And then your other 0 is at +2. We got it from here. It has a power of 1, so it also crosses. Okay, so let's graph it. Let's plot our zeros. So one of our zeros at 0. The other one's at -2. We're going in increments of 1, since it's -2 right here. And then your other one is at +2 and 2. And let's do our end behavior. So our most positive x-intercept is at 2, and it rises to the right like that. Your other smaller x-intercept is at -2, and it should also rise to the left like that. Okay. Now let's do our multiplicity. So starting with -2, it crosses. So you're going to just go right through -2. And then you're going to have to naturally curve like here, because you have to do your other 0, 0. Then at 0, it bounces. So you're going to curve here, and then you're going to make a little U curve because it bounces. Curve at 0. And then at 2, it crosses. So you're going to have to make another curve, and because it goes through exactly through 2. Okay. So yeah, that's how you graph that polynomial completely. Let's move on to an example 4. Sorry, it's a little bit slow. So example 4. Graph this completely. So let's start with end behavior. My end behavior, so the highest term is x4th. And it has coefficient 1, so there's no reflection. So what that looks like, it rises to the right, like that. Rise to the right and increase to the left. The next one is find your y-intercept. So plug in 0. That's 0 to the 4th minus 20. 0 squared plus 64, which is 64. So you have a y-intercept of 0, 64. Rule 3, find y, find your x-intercept, so set y to 0. And then how are we going to factor this? So we can't do grouping. We can't do simple because the power is greater than 2. We can't do quadratic. We can't do completing. So the last resort is completing the square. I mean, rational zero theorem and synthetic. Okay. So first we got to figure out our p. Our p is 64. And then all the factors of 64 are plus or minus 1, 2, wait. 64, 1 to 2. Yes. What about 3? No. How about 4? Yes. What else? 8. I think 16 would work. And then what about 32 works? And then what else am I missing? I think that's it. So it'd be 64. And then our Q is 1, and all the factors of 1 are plus or minus 1. So your possible zeros are P over Q, which is basically all this number over 1. So really your possible zeros are plus or minus 1, 2, 4, 8, 16, 32, and 64. Okay. Now we got to do synthetic. So you just pick one random possible zeros, and then if it gives you a remainder of 0, it works. So I don't know why, I'll just try -4. Oh, I remember, I put this. So I'm going to save you guys time. So one of my 0 is -4. So there's no shortcut with synthetic. You just pick one. If it gives you a 0, if it gives you a remainder of 0, that means it works. So let's try -4 and let's see if it really does work. And then make sure this is in order. So you are missing powers. So you start at 4. We're missing the power 3. We have a 2. We're missing the power 1, and then constant. So whatever missing power you have, just replace it with 0. So starting with x4, it has a coefficient of 1. We don't have a power cubed, so we're going to replace that with 0. Our power 2 has a coefficient of -20. And then we don't have a power 1, so replace that with 0. And then our constant is 64. Okay, put a placeholder under 0. So 1 plus 0 is 1. 1 times -4 is -4. 0 plus -4 is -4. -4 times -4 is +16. -20 plus 16 is -4. -4 times -4 is +16. 0 plus 16 is 16. 16 times -4 is -64. This gives you a remainder of 0, so that means it works. So you could say, if since -4 is 0, in factor form, it would be x plus 4. And what do we do with these numbers? 1, -4, -4, and 16. Those are your new coefficient of your new equation. So it would be 1x, and then our new power is going to be 1 less from your original highest power, which is 4. So 1 less of that would be 3. And then it's just going to be -4x squared, -4x1 plus 16. Okay, now how do we factor this? X cubed minus 4x squared minus 4x plus 16. You don't have to try a rational zero theorem. What's so special about this? It has exactly 4 terms. So we could try grouping by factoring. So let's try that. Split it in half. So between x cubed and negative 4x squared, you could take out an x squared. And then you have x minus 4. And then between negative 4x plus 16, you can take out a negative 4. So this comes out as x squared minus 4, and then x minus 4. And then x squared minus 4 can be factored out as x plus 2, x minus 2, x minus 4, and then don't forget x plus 4. Okay, so that means your zeros are, one of them is at negative 4. It came from here as a power of 1, so that means it crosses. Your other 0 is negative 2. It came from here. It has a power of 1, so it crosses. Your other 0 is at positive 2. It came from here. It has a power of 1, so that also crosses. And then your other 0 is positive 4. It came from here, and it also has a power of 1, so it also crosses. Okay, so let's plot it. Let's see. One of my zeros is negative 4. 1, 2, 3, 4. Your other one is at negative 2. 1, 2. Your other one is at positive 2. And then your other one is at 4. And then your y-intercept is at 0, 64. So our graph won't be at scale. Let's just pretend this is 64. Okay. So now let's do our end behaviors. Our most positive x-intercept is at 4, so it rises to the right. Our most smallest x-intercept is at negative 4. It also states it rises to the left. Okay, now let's do our bounce and cross thing. So at negative 4, it crosses. So you're going to go right through. You're going to have to eventually curve right here. And then at negative 2, it crosses. And then you have to pass through the y-intercept. So you're going to go all the way up here, making sure it goes through the y-intercept at 64. You're going to go down here. And then at 2, it crosses. So you're going to have to eventually curve here. And then at 4, it crosses. So this is your polynomial. Okay, let's do last example. Okay, example 5, we have y equals x cubed plus 5x squared minus 4x minus 20. So let's start with the end behavior. Our end behavior is the highest term, which is x cubed. It has a power of 3, so what that means is it rises to the right and decreases to the left, right? And yeah, so that's what it is. And then step 2, find the y-intercept. So you plug in 0. So it's going to be 0 cubed plus 5 times 0 squared minus 4 times 0 minus 20. And then put it all together, you get an output of negative 20. So your y-intercept is 0, negative 20. And then step 3, find the x-intercept and multiplicity. So you set y to 0. And it looks like we can try grouping because it has 4 terms. So split it into two parts. So on the first part, x cubed plus 5x squared, you can take out an x squared. And then this would be x plus 5. And then on the second part, negative 4x minus 20, you can take out a negative 4. So this would be x plus 5. So grouping does work because you see the x plus 5 repeats, so that means it works. So you write out the repeat once and bring down your leftover. So your leftover is x squared minus 4. Okay, and then x squared minus 4 can be factored, so it's going to be x plus 5, and then x squared minus 4 can be factored out as x plus 2, x minus 2. Okay, so one of your 0 is at negative 5. It has a power of 1, so that we know it's odd, so it crosses. Your other 0 is at negative 2. It came from here, it has a power of 1, so we also know it crosses. And then your other 0 is at positive 2. It came from here, and it has a power of 1, so we also know it crosses. Okay, so you have enough to graph it. So let's plot our zeros. So one of my zeros at negative 5, 1, 2, 3, 4, 5. My other one is at negative 2, 1, 2. And then your other one is at positive 2, 1, 2. And then my y-intercept is negative 20. So our graph will not be in scale. So let's pretend negative 20 is down here. Okay, so now let's do our end behavior. So our most positive x-intercept is at 2, and it says that it rises to the right. Our most smallest x-intercept is at negative 5, and it falls to the left. Okay, now let's do our bounces and crosses thing. They all cross. So at negative 5, it goes straight through, it crosses. So you're going to go through, and then you're going to have to eventually curve because it crosses at negative 2. And then you have to make sure you go through the y-intercept, which curves like this. And then it goes through at 2, so it goes like that. Okay, and that's it. That is your polynomial. Okay, I think that wraps it up for this section. So I'm going to stop.